Pydantic AI's capability model centers on abstract capability as the mechanism for bundling agent behavior. And the code below demonstrates how forRun isolates mutable state across runs by returning a fresh instance each time a run begins. A custom RequestCounter capability, subclasses AbstractCapability, overrides before model request to increment an internal count on each model request, and defines forRun to yield a new counter so that per run state does not leak between separate agent invocations. The setup registers this capability against an OpenAI, GPT-5, to agent via the capability's parameter, then runs the agent twice through agent run sync with distinct prompts, after which printing the shared counter's count reveals it stayed at 0 because each run received its own isolated instance. From data classes, import data class. From typing, import any. From Pydantic AI, import agent, model request context, run context. From Pydantic AI, capabilities, import AbstractCapability. At data class, class request counter AbstractCapability any. Counts model requests per run. Count int equals 0. Async def for run self CTX, run context any. RequestCounter. Return RequestCounter, hash fresh instance for each run. Async def before model request. Self CTX, run context any, request context, model request context. Model request context. Self count plus equals 1. Return request context. Counter equals RequestCounter. Agent equals agent OpenAI. GPT-5 2. Capabilities equals counter. Hash the shared counter stays at 0 because forRun returns a fresh instance. Agent run sync first run. Agent run sync second run. Print counter count 0. This capability uses forRun to create a fresh instance per agent run, isolating state across runs. The before model request hook increments self count on each model request, but because forRun returns a new request counter, each run gets its own counter that gets discarded after the run completes. The shared counter instance never sees those increments, so its count stays at 0. The pattern matters when a capability accumulates mutable state during a run that shouldn't leak into subsequent runs, like per run request counters, metrics, or caches. Without forRun, the shared instance would accumulate state across runs, which can cause data mixing in long-running agents. The trade-off is that you lose cross-run aggregation unless you explicitly design for it, like keeping a separate persistent counter outside the capability. Let's break it down. From data classes, import data class. From typing, import any. Imports data class for declarative class definitions, and any for unconstrained type annotations. At data class, class request counter AbstractCapability any. Counts model requests per run. Count int equals 0. Async def for run self CTX, run context any. RequestCounter. Return RequestCounter, hash fresh instance for each run. Defines a capability class that tracks model requests per run, with a counter field starting at 0 and an async forRun method that returns a fresh counter instance each time, resetting the count. Counter equals RequestCounter. Instantiates a request counter and assigns it to the variable counter. Agent equals agent OpenAI. GPT-5 2. Capabilities equals counter. Hash the shared counter stays at 0 because forRun returns a fresh instance. Instantiates an agent bound to the OpenAI GPT-5 2 model with a counter capability. The comment clarifies the counter remains at 0 because each run gets a fresh instance. Agent run sync first run. Invokes the agent synchronously with the prompt first run,
blocking until the response completes and returning the result.
Agent runsync second run.
Invokes the agent synchronously with the prompt second run, returning a completed response.
Print counter count 0.
Prints the current value of counter count, which is 0. For run is the hinge. It's what turns a single shared capability instance into per run isolation. Before model request does the counting, but the count lives on the fresh instance. For run hands out each time agent run sync is called. So the shared counter variable stays at 0 because it never actually participates in any run. It just sits there, registered with the agent, while each invocation gets its own request counter that gets thrown away when the run ends. The trade-off is simple. Isolation prevents data leaking between runs, but you lose any cross-run aggregation unless you manage state separately outside the capability.
The shared counter sleeps, while every run births its own instance into the model request.